Thank you for coming. My name's Paul Quinn. I'm from HSBC. I work in the global markets area of the bank. Thank you for your time this morning, and I hope I can do the subject matter justice and get the message across. I would have taken questions, but I think it's probably the wrong forum for that. So if you want to catch up with me at the end and ask any further questions. I need to be visual to get my message across. So there's lots and lots of pictures in what I do. The primary agenda for today is integrated runtime using data and process models run via an ETL where we build up the process models from the runtime process models from the data models themselves. We're speaking about METAL. It's an acronym we've made up which stands for Models and ETL. It's some innovation that we're doing at HSBC to drive through adopting process runtime models from data models. What we're trying to address is the vicious cycle that that large institutions tend to get themselves into by never-ending fallouts of integrating multiple processes across multiple sources of data, across multiple consumers of data, and all doing their own siloed activities, all doing their own siloed staging, persistence, transformations, etc. I don't want to get into the sources of the root causes of all of those issues. What I wanted to start to deal with is what we're trying to do to drive through and deliver via automated process models to fix that issue. What we're doing is taking data models stored in a dedicated data modeling tool and pushing them through a process modeling tool that is then used for runtime. What we find at the moment in the problem statement is that we end up with multiple data sets that are not correlated in our world. That might be finance, that might be risk, that might be regulatory functions. We end up with duplications of data set as each stream and each silo does what it needs to do to persist the data, to transform the data. We end up with additional business processes and teams to correct that. That might be reconciliation teams, that might be reporting teams to report to regulators. And finally, we end up with a bit of a problem when we come to BCBS 239 and speaking with our regulators and showing how all of our data sets are aligned and in sync. Again, I'm quite a visual person, so this is me trying to give people an idea in a very simplified format of what tends to happen. So we end up with multiple sources of data, multiple consumers, each doing their same thing, whether it's homogenizing, transforming, or whether it's staging and persisting. What we end up with, of course, is a difficult governance landscape as we're all doing our own transformations, and what starts out as a counterparty in one system ends up in God knows what another. We have all of our data models and the way we do our transforms lost in multiple forms, multiple places around the place, therefore it's not common, and the data sets all start to diverge. We end up with a very heavy reconciliation process as we try and integrate our various teams, whether that's finance, whether that's risk, whether that's reg reporting. None of it really ties up, and we have to do massive reconciliation processes to try and fix it. We have repeat consumer investment. Everybody invests in a new staging layer. Everybody invests in a new consumer set. Everybody invests in transformations. And finally, all the hardware investment that goes with that. So, trying to break out of that vicious cycle and into a virtuous circle by doing, as I said earlier, creating runtime environments built off the data models, creating process models built off the data models, where we model our data sources. We make process models out of those data models and then run it across ETL tooling. This is where Clover helps us, and this is what makes our data models run-timeable or actionable. What that means is our data and process models get expressed as runtime processes, and we take our meta sources and all of our transformations, and the cherry on the top is that out of this, hopefully we get much stronger governance, much stronger lineage. We can align it to a group information model, and we get the ability to visualize both the data models and the process models via the tooling. It allows the models and the data models and the process models to be constantly leveraged again and again and again. Everything is cataloged because it's stored in data modeling tools. Everything is then available in graph databases for visualization. Again, more visualization from my end. Broadly, what I'm saying here is we have modeling tools, a bridge function to pick up all the data models, push them into your ETL tooling, allowing you to build up process models from those data models. So, the primary components or ingredients for this function are a data model repository where everything that's modeled, a data modeling function that takes every model that's ever done, whether it's a modeling of a data source, modeling of a data consumer, or the models, the transformation, mappings, etc., that then join those two data sets. We bridge that across. They become available as objects in the runtime process where we build up process chains to make end-to-end graphs. What it means is the data models themselves, which are common to everybody, become available as runtime processes common to everybody. And each consumer slowly pulls it apart to build up what they need. Or should I say, rapidly pulls it apart to build what they need. What does this enable? It enables our runtime process created using common and controlled foundational data models, a single definition and common use of foundational data models, a single capture and common use of mappings, i.e., when we transform one or more fields to mean something, everybody gets to use it. One team doesn't do it in silo from another team and another team and another team that just creates that horrible wreck and alignment later on. We have a data model bridge that pulls all the models to make them available to us to build up our process model chains. It also provides us with a single point of governance and this capability to run single point validation across all of the data that flows through the system. So, the next graphic, where I'm trying to make this a little more tangible rather than just an architecture chart. Here we've got a schema where we are saying trade and valuations, market and reference data stores, the runtime environment and our consumers. We capture the meta structure of all of these sources of data. We capture the meta structure of all of our consumers. We run that across a data model bridge. We capture all the transformations, mappings, configurations, run that all across the bridge, and then in the ETL tool, build up our process chains by literally dragging across. Join this primary data source to this mapping, to this transformation, to this output format, and then it becomes a runtime process that just goes. With the definition of the sources and their output comes the connection strings to our sources and the format and the output and the connection strings to wherever we're going, whether that's a Solus queue at the top or a database at the top to a Solus queue at the bottom or a database at the bottom. What does it enable to do? Again, we migrate to a common set of data models and fields that all consumers for each golden data source. Alignment to common mapping, transformation, and rules-based functions to ensure consistency across all consumers that you adopt this. Leverage and reuse of both the data models themselves and the process models. That needs to be translated into a runtime, as in what do prod support or whomever's doing it at the end of the day, what buttons do they push? Again, what we have is metal, joining and mapping, everything. We have metal connects to all of our sources. And then we have metal publishing out to all of our consumers. For the purposes of clarity, back to, I know that I need to reinforce this one. The metal is just an acronym, model ETL, ETL being Clover, ETL being the bridge that allows us to enable us to do all this, make these runtimeable processes. What does this enable us to do? Again, migration to common extract patterns. Doesn't matter who you are, doesn't matter what you're doing, it's the same extract pattern. Connect to the same data source using the same data model, using the same connection string to pull that data, harvest that data. Uses the same transformations to deliver. Yeah? The same process to connect to multiple consumers. Doesn't matter who's doing it, they're all defined, they're all mapped, they're all modeled. And the same mappings. So, hopefully, we have a pick list or a smorgasbord of objects to pull into our process chains, and then a pick list of process models you might want to change or update or indeed leverage in its entirety to deliver to your consumer. Finally, back to the cherry on top I spoke about earlier. As a runtime function, as a runtime tool, this is a phenomenally powerful thing to do. It allows you to, whether it's running hundreds of thousands, if not actually millions of hundreds of millions of tests across data sets, fast-moving data sets, whether it's doing batch processes of end of day, one of its greatest benefits on the side is that we can hook up to our lineage, visualization tooling, our BCBS 239 functions, our group information models, because they are all just modeled. You model them as data sources, you join them up, you can infer data models via data lakes. I should say we are inferring data models from data lakes, from all of that history of mess, quagmire that exists across our thousands and thousands of feeds, etc., and data stores. We can infer relationships via a data lake and then test them via this function. If that makes sense. Back to the cherry on top. What does that give us? The ability to capture the group's information model, align that to all of our data models, our consumer and source-specific data models, provide governance, capture lineage from the data lake, ingest all of those things as well, line them up, and now we can visualize this, whether it's via an MI tool or whether it's via a graph database in the form of triples. What does that enable us? BCBS 239 broadly comes for free. Everything's in a data modeling tool, therefore the lineage, regardless of whether it's the data models or the process models, it comes for free because it just gets expressed as triples that we hoover up either into a reporting tool, Tableau, Click, whatever, or we display in a graph database. So, where are we at the moment? We're part of the way down a journey. We're using a lot of this in production, so it's real. It works. It's going. Our two primary use cases at the moment, and the volume of use cases are growing and growing and growing, is an intraday near real-time use case where we're doing validations on trade messages, a couple of million a day, and we're performing a couple of 100 million tests on that data set all day, every day. This thing's delivering down at 500 to 800 messages a second to a Solus queue, pulling off a Solus queue as it does this all day. As I say, high volumes of small data sets across message queues. The second set is end of day where we've got small volumes of very large data sets. Again, data extract, joining and transformation, as opposed to sit there, read, validate, pass on. Sit there, read, validate, pass on to a workflow tool at the bottom. And MI and governance. We have a harvester that literally pulls all of the data models and all of the process models and turns them into triples. And those triples are then simply available to an MI tooling, in our case, Tableau, and a graph database, in our case, Neo4j, for visualization and to facilitate who can do what. As you can imagine, there are thousands of attributes in our data models now because it represents all trade messages, all the FPL messages that we work with. It represents all of the reference data sources we use. That might be a pile of securities. It might be a pile of counterparties. And they are all available to us in a model form that we can pick and choose. But there's no point being available to us if we don't have a good, strong visualization tool and the commensurate ability to say, no. Why is that orphaned? That shouldn't be there on its own. It shouldn't be the only use case. Everything should be repeat use case. A few lessons for us. The data models are all powerful. Do it right, do it first time, focus on it, get the knowledge in-house, get the knowledge learned up, get the right tool, and get your data models correct, regardless of whether that's the data models of the sources, the data model of the targets, and the mappings, et cetera, et cetera. It's important. We clearly can't have a bridge that just can read any old transformation, so don't make a 3,000-line MSL or XSLT that will crucify this thing. Break it up into small packages so that it becomes evident and obvious and reusable for whatever anybody wants to do. Back to that, the data model bridge is the key to unlocking the power of the models. Model everything, control it, stop writing scripts and things, configure it, put it into a data model. Run it across the bridge gives you a pick list of items to pour into your ETL process and then create your process. The migration of data models to process models is iterative. It's not just a chuck it and forget. This is here's the data models, integrate it, it works. Oh, this needs a twist. We need to put that sort before that join or whatever. It's iterative. If you do it right, it scales almost linearly. If you're starting to max out, fine. Get a couple of licenses, get a few more servers, and off you go. It scales beautifully. Unless, I'll come to that in a minute. Memory availability is critical. We're finding memory availability a much bigger factor than we are finding CPU. It kind of makes sense in the terms of a large financial institution. The data sets we work with are massive, so if we do have to cache up data sets, it starts to get intensive. Comes down to that hardware decision. Make sure, if you are using virtual servers, make sure that you think about your memory. So if you're getting virtual servers with a reasonable CPU on it, put some reasonable memory next to it. Take some discipline in what you're doing. Learn it. Don't just chuck it and forget because it will bite you. It will bite you. There we go. I don't need to finish that sentence. Don't create the next vicious cycle. If you do, it will bury you. So the next few slides is me now kind of just giving you some diagrams of what this thing looks like when you do it. So this is IDA, an Eclipse front end. I hope I'm not going to get into trouble from IBM for showing you this screen. On the left, this is a left-click ingest the meta structure, whether it's a database table, whether it's an XML message, whether it's a CSV, whether it's whatever, don't care. Right-click of our data sources. Same things for our data targets. Whether it's a cube, whether it's an active VM cube, whether it's an object on a cloud, doesn't matter. Right-click, get the meta structure, suck it in. It becomes available. Source, target, mappings. As I said before, you can make these as basic or as complex as you like. My simple advice is don't make them complex. Put some hops. Hop, hop, hop. The more complex you make this, the less reusable it is. This is, and again, an Eclipse front end, and this is one of the Clover front ends. What you've got here is all of the objects that have been modeled from here. These are models. We run the bridge, and they turn up in the palette on the left for a drag and drop to build up our processes. In this case, you probably saw I've tried to keep to the colors: green, yellow, blue, sources, transforms, targets. And because this is a drag and drop into here, if you try and join a data source or any data set to a transform and the meta structure don't align, it just doesn't work. Because all of this is model driven, every object connects or doesn't connect. And if it doesn't connect, you pick the wrong object. Simple as that. Build it up, end to end, and it just goes. Becomes part of a runtime process. This is us having done all of our data models, having done all of our process models, sucking it all out via a harvester, turning it into triples, and now we're expressing these triples in Tableau in this case. And what does this allow us to do? We can govern our data models. We can source and target attributes used in our mappings. We can create attribute catalogs as well as source catalogs as well as target catalogs. And it's Tableau. We can do what we like. We can filter on it, we can report on it, etc., etc. The pretty one's the next one. This is expressing the same data set again. This same data set in a graph database. Again, triples. What does this allow us to do? This allows us to give a very pretty and very handy, useful flow of how models and processes are used to build up an end-to-end chain. How do we go from multiple data sources to end-to-end deliveries? Regardless, again, whether the end is a cube, whether the end is a valuation engine, whether the end is a report, this allows us to track everything we do. It's a great enabler for developers and modelers to build up what they need to do. So, that's probably the end of my show. I'm not sure how I am for time. Don't know whether I'm long or short. Bang on. Great. I've got 5 minutes. I don't know whether they're going to pass a mic around. No? Right. Any questions? It's going to be tough.
We have a mic?
No, we don't have a mic.
So if something in the data flow changes, is it propagated automatically?
Yes. So the question for everybody is, if something in here changes, the only way it can change is because something in here changes. Yeah? We get a change to a data model, we get a new object code, we model or we change a model. When we run the bridge, it's add, subtract. It only sends across what it needs to change, and then we just modify this object, and it's fine. Propagates fully through the chain. Yes. Any other questions? Thank you very much.